Hello all, good morning. This is Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Multiple Integrals. Now we have an introduction regarding the multiple integrals, which will be according to a double integral or a triple integral. First of all, we will look on to double integration and its problems. In introductory part, application of multiple integrals are to find area and volume of various bodies just by taking a little part of them into consideration, which means by integration we can make the area and volume of the bodies which wherein we will consider the only a part of them and we will expand it to the other whole parts. Now, double integration in Cartesian coordinates. A double integration is computed by repeated single variable integration. So we will use a single variable to integrate. That is by integrating with respect to one variable, treating that other variable as constant and denoting it as I. So what is our I here? I is double integral over the region R dx into dy, where R is the region to be considered. Whatever region we are considering, we will name it as I. I is naming for integration. Now we will have some of the problems regarding double integration. First problem, integral 0 to 1, integral 1 to 2, x into x plus y dy dx. This is our problem. So here, since these limits are numerical values, we can consider this to be for y variable and this to be for x variable. So the first, the inner integral will be considered for the inner variable and the outer limit will be considered for the outer variable. Now here the inner limit is for y and the outer limit is for x. Now what is our I? I is integral 0 to 1, 1 to 2, x into x plus y dy dx, x into x plus y dy dx. On multiplying this x inside the brackets, you will have x square plus x into y. X squared plus x into y. So this is what we have got in this particular step, second step. Now what we are going to do, we are integrating with respect to the variable y. We are integrating with respect to the variable y. As we know all the simple and minor formulae, we will just integrate it using the formula. What is our formula? It is x power n. On integrating x power n, you will have x to the power n plus 1 divided by n plus 1. This is your formula. Using this formula, you can integrate it. Now we have to keep this x as constant. And you have to integrate with respect to the variable y. So on integrating this, x square will remain the same, and on integrating this x into y, you will have y alone, x square into y plus x into, on integrating this y, you will have y to the power 1 plus 1 by 1 plus 1 within the limit 1 to 2. This is for first integral. Now this is into x square into y. X square into y for the first term and x into y to the power 2 by 2 will be for the second term. Now moving on to the next step, what we are doing, we will just implement the upper limit and the lower limit. What is your upper limit? 2. What is your lower limit? 1. So upper limit we are applying only for y, all the y's here. So we have got 2 and 2 here. And lower limit we are applying for only this y here and 1 for all the y here. So later what we will get, we will just get the simplified term only with the variable x, because we have eliminated y. So what will be our y? What will be our x here? 2x square plus 2x minus x squared minus x by 2. We will combine these like terms, all these like terms. If we are combining all these like terms, we will have x square plus 3x by 2 into dx. Now this is as usual integration with a single variable. Now what is x squared integration? It will have 2 plus 1 divided by 2 plus 1 plus 3 by 2 into x to the power 1 plus 1 divided by 1 plus 1. Now on simplifying it, you will have the value to be x cubed by 3 plus 3 by 2 into x squared by 2 minus 0. Minus 0 after applying the limit, but before applying the limit we have to apply it for this x alone. This 1 should be applied for x alone, therefore this will be 1, this will be 1, this will be the lower limit. Here you will not have this. Now what will be the simplified term? It is 4 plus 9 by 12, which is equal to 13 by 12, which is 13 by 12 is the final answer. 13 by 12 is the final answer. So what we have got, or what we have inferred here is, we have just inferred that the area of the given curve, the area of the given curve here is 13 by 12. Is 13 by 12. So likewise, we will compute problems on area using multiple integrals with the definite limits. We will have some more problems in the next class as well.